Hi, I'm Ms. Bull and today is the fourth video of circular functions and we're reviewing trigonometric ratios. It should be an easy video because you should have done this in year 9 and 10 already. So remember, sine is equal to O over h, or opposite of a hypotenuse. Cos is A over h, or adjacent over hypotenuse, and tan is O over A, opposite over adjacent. And one way to remember is SOH, you read it as so, CAH is car, and TOA is toa, toa. Let's do some examples. So first of all, we have to make sure that we can use the Cad Calculator. So I'm just going to turn on the Cad Calculator and evaluate this with you. Ignore this from the previous video. So to find sine of 25, we will go to, I'm going to bring it up again so you can see where I've typed. Keyboard, trigonometry, sine is right there. Make sure that we are in degrees, so DEG. And then 25, enter, we have 0.42. I'm going to take the CAS away. So I'm going to leave you with a few questions. Cos 25, see if you can do that. Should get that answer. Tan, and etc. So one way to do this is to write down these questions, pause the video, type them into your calculator so write down the answers, and look up to check that you have the same values. What else do you have to recall from previous years? Finding the size of the angle corrected to the nearest degree. So here we have a triangle. What was the first step? The first step is to label it. So we have hypotenuse, that is the adjacent, and that is the opposite. So then we look at sine, cos, tan, so katoa, what are we dealing with? We have O and A, so 5 and 11 is O and A, so we must be dealing with tan. So we write tan theta equals to O over A, 5 over 11. And to get rid of tan, we do the inverse of tan. So inverse tan 5 over 11 will give us the angle, which is 24 degrees. And because we're using a different calculator to year 9 and 10, let's just do that to double check. So we're working in degrees again, so check that we are in degrees down here. Then inverse tan, so again, it would be in keyboard, trigonometry, inverse tan is over there. And we're doing 5 over 11, close bracket, enter. So 24.44, so 24. Next example. So this should all be revision. Again, find the angle. First step, what do we do? Label it. So that is obviously the hypotenuse. And we have the 3 is our opposite, and adjacent is next to the x, which is over there. So we see that we're looking at O and H. So out of SOHCAHTOA, we are looking at sine. So we write sine x is equal to O over H, which is 3 over 9. So to find x, we have to get rid of sine, so inverse sine on both sides, and we obtain x equals to 19 degrees. Make sure you try that on the calculator and you can find the buttons on your own. If you can't, then rewind the video to the previous example so you can find where the buttons are. Make sure you can do it on your CADs, not just your little scientific calculators. Use trigonometric ratios to solve for x corrected to decimal places. So now we have a side that we're looking for, not the angle. So we label it first. Same. The first step is always the same. We have to label it. So we have hypotenuse over here. This is next to the angle, so that's the adjacent, and that's opposite to the angle, so that's the opposite. And we're dealing with O and A. So out of SOHCAHTOA, what is O and A? It will be toa, tan. So let's write it out. Tan of the angle is equal to opposite x over adjacent, 11. And now we have to find x. So we need to get 11 on the other side. So multiply both sides by 11. So 11 tan 42 equals x. So x is equal to 9.9044. And 2 decimal places, 9.90 centimeters. That 0 is important when it asks for 2 decimal places. What about this one? This time we have hypotenuse and we have the opposite. So hypotenuse and opposite, what are we dealing with? Sine. So sine theta is equal to opposite over hypotenuse. which is 9 over x. And x is what we're looking for, but it's at the bottom. So let's multiply both sides by x. Now we need to get rid of what's next to x, this whole thing, so divide both sides by that. So now we have 9 over sine 29 degrees, which is 18.56. Let me put the two examples right next to each other so we can compare our working out. So here we have adjacent and a hypotenuse. And on the other side we have, an opposite. And over here we have opposite, hypotenuse and adjacent over there. Now with adjacent and hypotenuse we are working with cos. So cos 90 degrees is equal to adjacent over hypotenuse, so x over 5. So here we have to bring the 5 over, and we have 5 times all of that to get us x as 4.94. On this example, something is different. So we have sine 30 degrees because we're dealing with opposite and hypotenuse, O and H. So opposite over hypotenuse is 3 over x. But now we have x at the bottom. So we have to bring x to the left side and then bring all of that to the right side. So now when we plug that in the calculator, we get 6. But what I want you to see next to each other is if the x is at the bottom, then we have to switch these two and you end up with 3 divided by something big. Whereas if x is at the top, we're just multiplying those two values together. It's a common mistake. So you have lots of questions and you get carried away. Sometimes you might be used to just multiplying them through. Be careful, sometimes there is division. Thank you for watching and I'll see you next time. Bye.